Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring dilations and measurement. So in example 1, it says complete the requested information for each dilation. So in our original rectangle here, we have a rectangle that's 9 foot by 12 foot. If we wanted to calculate the perimeter for this shape, we could add all 4 of the sides, or we could say there's 2 sides of 9 plus 2 sides of 12, and then put that in our calculator. 2 times 9 plus 2 times 12, and that will give me a perimeter of 42 feet. Okay. If I'm asked to find the area, then we simply multiply the length 9 times the width 12, and that gives us 108. So 108, and area is measured in square feet. All right. Now, if I took this same rectangle and I dilated it by a scale factor of 3, then my new dimensions would become 9 times 3 would be 27, and 12 times 3 would be 36. So my new perimeter would be 2 times 27 plus 2 times 36. Let's see what that gives me. 2 times 27 plus 2 times 36. That gives me a perimeter of 126 feet. The area would be 27 times 36, and that would be 972 square feet. All right. Now, what if I took that first rectangle, the 9 by 12 rectangle, and what if I dilated it by a scale factor of 1/3? So 1/3 of 9 is 3, and 1/3 of 12 is 4. So now my perimeter would be 2 times 3 plus 2 times 4. Let's say I can do that in my head. 6 plus 8. So I would have a perimeter of 14 feet. And my area would be 3 times 4, or 12 square feet. Now, in example 2, we're going to explore how does multiplying a shape by a scale factor, how does it affect the area, and how does it affect the perimeter of a rectangle, or any shape really. So in problem 8, it says if an image increases by a scale factor of 3, by what factor will the perimeter increase? So I'm going to take the new perimeter divided by the old to see how the scale factor of 3 affected the perimeter. So my scale factor of 3, my new perimeter was 126 feet. My original perimeter was 42 feet. So let's divide that. 126 divided by 42. All right. So if our image is increased by a scale factor of 3, the perimeter will also increase by a scale factor of 3. All right. Problem B, if an image increases by a scale factor of 3, by what factor will the area increase? So again, this time we're going to see how the area is affected by a scale factor. So our new area, when we had a scale factor of 3, was 972 square feet. Our original area was 108 square feet. All right. So 972 divided by 108 gives us a 9 times. So when we increase an object by a scale factor of 3, the area increases by a factor of 9. All right, problem C. If an image decreases by a scale factor of 1/3, by what factor will the perimeter decrease? So now we're looking at the third shape, scale factor of 1/3, and we're going to compare the new to the original. So our new perimeter was 14. Our original perimeter was 42. So let's put that in our calculator. 14 divided by 42. I want to turn that into a fraction. All right. So if an image decreases by a scale factor of 1/3, the perimeter will also decrease by 1/3. All right. If an image decreases by a scale factor of 1, this should say 1/3, by what factor will the area decrease? So our new area was 12 divided by the original area, which is 108. So 12 divided by 108. Turn that into a fraction. So the area decreases by a scale factor of 1/9. All right. Now let's summarize these findings. Effects of a dilation on a perimeter. When a figure is dilated by a scale factor of k, its perimeter will also change by a scale factor of k. So the new perimeter is equal to the original perimeter times the original scale factor. Okay. Now let's look at the effects of scale factor, the effects of dilations on area. When a figure is dilated by a scale factor of k, its area will change by a factor of k squared. So it's the new area is equal to the original area times the scale factor squared. So for perimeter, you just multiply it by the scale factor. For area, you multiply the original by the scale factor squared. Now let's look at some examples showing this. In example 3, it says answer each of the following. In part A, it says a figure will be dilated by a scale factor of 5. Explain how the perimeter and the area will be changed. So the perimeter of the dilated figure will be 5 times the perimeter of the original figure. But the area of the dilated figure will be 25 times the area of the original figure, because 5 squared is 25. So remember, perimeter, just multiply by the scale factor. Area, multiply by the scale factor squared. All right? So a figure will be dilated by a scale factor of 3/4. By what factor will the perimeter and the area change? So the perimeter of the dilated figure will be 3/4 times the perimeter of the original figure. The area of the dilated figure will be, we need to take 3/4 and square it. Hit the fraction. And that would be 9/16. So square the 3 to get 9, square the 4 to get 16. Okay. All right, a figure will be dilated by a scale factor of 0.6. Explain how the perimeter and the area will be changed. Pause the video and try problems C and D on your own. When you're ready to check your answers, press play. All right, welcome back. I said the perimeter of the dilated figure will be 0.6 times the perimeter of the original figure, and then I squared that, 0.6 squared, and I got that the area will be 0.36 times the area of the original figure. Okay, in problem D, I said the perimeter will be 2.5 times the perimeter of the original figure, and the area would be 6.25 times the area of the original figure. All right. Example 4. The equilateral triangle below was dilated by a scale factor of 4. What is the perimeter of the dilated triangle? So the perimeter of the original triangle is 30. So if I want the perimeter of the new triangle, I take the original perimeter and multiply it by the scale factor. So that new perimeter would be 120 inches. All right. Example 5. The equilateral triangle below was dilated by a scale factor of 1/2. What is the perimeter of the dilated triangle? So I want to calculate the perimeter of my original, which would be 15 times 3, or 45 feet. So the perimeter of my dilated factor, you take your original perimeter and you multiply it by the scale factor. So 45 times 1/2 is 22.5 feet. So you just multiply the original perimeter times the scale factor. Okay. Example 6. The rectangle below was dilated by a scale factor of 1.5. What is the area of the dilated rectangle? So first we have to find the area of our original rectangle, but they only gave us the width. We need to know, or they only gave us the length, and we need to know the width. So I know the perimeter all the way around. This rectangle is 32. And I know the top and the bottom add up to 20. So if I subtract those, I get 12 centimeters left that I have to split up between each of the two missing sides. So I know this is 6 and this is 6. So the area of my original figure is length times width, or 60 square centimeters. Now, if I'm going to dilate this shape by a scale factor of 1.5, how would the area, what would the area of the new rectangle be? So you take your original area, which was 60, and you're going to multiply it by the scale factor squared. Remember, for area, you have to square the scale factor. So I'll just put that in my calculator. Let's see, 60 times 1.5 squared, and that would give me 135 square centimeters. All right, pause the video and try example 7 on your own. When you're ready to check your answer, press play. All right, welcome back. Let's see. I need to know my missing sides here. So my top and my bottom are 12. 12 plus 12 is 24. So this would be 18. I have 18 feet that I need to split up between the two sides. So I know this is 9 and this is 9. So the area of my original shape is 9 times 12, which is 108 square feet. Now, to get the new area, I have to take the original area and multiply by the scale factor squared. So I'll use my calculator to do that. 108 parenthesis 2/3 side arrow parenthesis squared. And that will give me 48 square feet for the area of my new shape. And that concludes today's lesson, Dilations and Measurement.